Good evening, everybody. Thank you for joining the webinar series sponsored by the ASQ Innovation Division. Tonight, we have a webinar titled Industrial Neurodiversity and the Future of Quality Management in Production Systems. And the presenter is Dr. Nicole Raswell. Nicole is an associate professor of production systems in the Department of Integrated Science and Technology at James Madison University in Harrisonburg, Virginia. She is a fellow of the American Society for Quality and is a certified Six Sigma Black Belt and certified manager of quality and organizational excellence. She has a PhD in quality systems from Indiana State University, and her research focuses on the intersection of quality, innovation, and neurodiversity in cognitive production systems. She is one of ASQ's new voices of quality and participates in ASQ Influential Voices with her blog at qualityinnovation.com. In today's webinar, she combined analysis from 2015 ASQ Future of Quality Report, publications from Deloitte Consulting Center for the Edge, and her own research. The topics you will cover will be to share stories that explain exactly how products, customers, and organizations are changing. Describe the interrelated forces enabling these shifts, including smart manufacturing, ambient intelligence, the Internet of Things, virtual and augmented reality, continuous learning, and situated analytics. Present a neurodiversity model of industry where different ways of sensing, communicating, and socializing are viewed not only as liabilities but opportunities for increasing innovation. Explain why maker culture is influencing business model innovation for everyone, and assert that quality is no longer possible without cybersecurity. As we aim for innovation across our industries and sectors, it is critical to understand how our own practice of quality management must adapt. This webinar will take a first step toward empowering you to understand the new technologies and social organizational contexts that will drive those shifts. So without further ado, let me introduce you to Nicole Raswell. Nicole, please take it away.
All right. Hi, Jose. Hi, everyone else who's on the webinar tonight. I just wanted to give you a little background as to what the motivation was for putting together this presentation. Along with my colleagues at JMU, we've just started the process of revitalizing our curriculum in production systems. We used to have a 21 credit sequence in engineering and manufacturing that was a little more traditionally oriented towards manufacturing engineering. But what we wanted to do was we wanted to make the curriculum more dynamic. We wanted to prepare our students for the jobs in production systems that don't exist yet, that won't exist for another 10 or 20 years. And so when we took a look at what sorts of topics we thought were necessary to educate students on now so that they can help lead our fields in another 10 to 20 years as the landscape is changing as far as technology is concerned, as far as global challenges, some things stood out. One of them was we needed to give them a really solid foundation in sustainability and in the management concepts associated with sustainability engineering. It was going to be very critical to educate them in continuous improvement, which is something that those of us who work in quality management focus on quite a bit. But then we also wanted to make them aware of the changing technological landscape, because when you're putting together your business models, it's really important to understand where your opportunities are, where the edges are of your innovation landscape. So the presentation that I'm going to share with you guys tonight is intended to give our students a little bit of a forward look at where production systems are heading, and so and some models also for taking a look at that. So we're going to tie together lots and lots of different concepts, and what I hope that you all get out of this is to see how several of these different technological pieces fit together and also to leave you with some resources that you may not be aware of yet that may benefit you in your job down the road. So that's where we're heading today, to give you kind of a look at the landscape of quality and innovation moving forward, and to leave you with some of those tools that you might be able to learn more about and apply to your own job. So like Jose said, my name is Nicole, and I work at JMU in Virginia. So that's a picture of our actual ivory tower up at the top, and then there's me down on the bottom, in case you're wondering what I look like. And just to highlight what we're going to be talking about, we're going to be focusing on one question. And that question is, what does quality management look like when the boundaries between humans and machines are ambiguous? And that's the whole shift that we're going to see over the next 10 to 20 years. There's people in our workforce. There's increasingly going to be machines in our workforce. People are worried about machines and automation taking over the jobs of humans, but I think what we're going to see is humans leveraging those intelligent machines and those intelligent agents in ways that really create a hybrid workforce. So we're going to be working together with machines to achieve our quality goals and to achieve our goals as far as working together. So we've brought together analysis from lots of different sources in this presentation. One of the key sources that got this started was the 2015 ASQ Future of Quality Report. ASQ puts together one of these reports every few years, and the one that they did in 2015 took a little bit of a different turn. Instead of trying to be prescriptive, the Future of Quality Report looked at some of the larger changes that might be going on, maybe the forces driving innovation. So it took a little bit of a different perspective. We also draw from Deloitte Consulting's Center for the Edge. Center for the Edge is a think tank essentially that focuses on production systems and manufacturing. They're based out of San Francisco. And so we have started collaborating with the Center for the Edge so that they, from the things that they learn on the ground, talking to some of these new production systems players, we want to weave that into our curriculum. So we're going to be sharing that with you tonight also. There's lots of different technologies that I'm going to mention and bring together. Some of them you may have heard of, some of them may be new to you, but really what our challenge is right now as people who are involved in quality professions and people who are interested in innovation is just understanding these are several technologies that are going to influence our ability to create new business models and innovate on our existing business models. So we're going to step backwards. If you look at the title is Industrial Neurodiversity, the Future of Quality Management in Production Systems. So I'm going to move backwards. I'm going to start with production systems, then I'm going to talk about future quality management, and then finally, at the very end, I'm going to introduce you to a model for thinking about our organizations that brings together this concept of how humans and machines can work together very proactively in that hybrid environment. So production systems, it's a very broad term. Our curriculum that we teach courses in is intended to cover not just the traditional manufacturing and heavy industry sector, but everything from craft and artisan work all the way up to even if you're bringing together your supply chain by being a broker between different organizations and different sources. So I like to think of production systems as anything that you can characterize by a SIPOC diagram. Hopefully all of you have seen SIPOC diagrams where you link together your suppliers and then the inputs and then the processes that you use to transform those inputs into value, the outputs that represent the value, and then the customers that are on the receiving end of that value that you deliver. So this doesn't just include making products. It can also include services and alternative business models where you act as a broker, or alternative business models where you create information products. And the core driver of all the changes that we're seeing and are going to see over the next several years is wireless communication. So those of you who have worked in manufacturing plants, you may recall that even 20, 30 years ago there was a high degree of automation in those plants. But what's changing is that each of these components in our industrial systems is increasingly wireless capable. So these things are connected to the internet, or they're either by Ethernet or by IPv6, and so that level of connectivity is what's causing the shift. So in production systems, quality is one of our core concepts, and the definition that I like to use to ground me whenever I'm thinking about quality is the one that comes from ISO 9001. And that is, the quality is the totality of characteristics of an entity that bear upon that entity's ability to satisfy stated and implied needs. And it's really interesting. I've used this definition in many different contexts, and if this is the only definition you use, it can really help people outline and articulate and kind of to break down all of the aspects of their system that they need to pay attention to in order to design quality and also to assure quality. So you have to think about it not just from the perspective of the quality that you design into your product, but also the quality of the production process. And most of us are very familiar with that concept of quality that has to stretch from before you're envisioning what it is you're going to put together all the way until your customer is able to perceive that value after they have either purchased your product or been part of receiving your service. So the next thing you have to think of is, what does this mean in terms of innovation? What's the link from quality to innovation? And I really like this definition because it makes it very easy for us to define innovation. We can just say it's the totality of characteristics of an entity that bear upon its ability to satisfy future needs. And so this aligns very well with the Innovation Think Tank Executive Summary that came out in 2013 that was put up by ASQ. And the definition there is that innovation is quality for tomorrow. I believe that definition emerged from Peter Merrill, and it fits very, very well with the ISO 9001 definition of quality. So that's kind of the basis that I use to think about innovation. It just means, am I designing quality into those value generation systems that will be used to deliver value in the future? So all production systems are guided by business models, and the way I like to think about business models is a definition that is espoused by University of St. Gallen in Switzerland, and there's a link down at the bottom for a resource that I find amazingly useful. Their business model navigator contains 55 different design patterns that you can, I think they even have a card deck that they've produced where you can flip through the cards and just kind of try on different business models, all of which contain the answers to 4 questions. All business models are stories. They just address who, what, how, and why. What is this value that you're going to deliver? Who are you going to deliver it to? What processes, what structure do you have in place to deliver that value? And by understanding the answers to these 4 questions, if you're trying to innovate on your business model, if you're trying to introduce new technologies, you have to make sure that you're increasing your ability in one of these areas. And the guideline that this business model navigator puts forth is that business model innovation includes changing 2 of your answers to these 4 questions. So here's an example of that. This is an example of business model innovation with respect to those 4 questions for Skype. And although this particular structure, although they say you only have to change 2 of the who, what, how, or why to achieve business model innovation, this example right here shows 4 different possibilities for how you could innovate on your business model. So just to touch on the one on the right in the how section over there. So one of the old ways that Skype did business is that they owned all of their own telecommunication infrastructure. Obviously that's probably a very expensive way to do business now that cloud computing is so much more prevalent than it was when Skype first started out doing its business. So Skype has moved to, instead of delivering their value by owning and maintaining their own infrastructure, they've been able to move that completely to the cloud thus reducing their costs and improving their ability to deliver value to their users. So this 4-point model just provides an easy way to understand, number one, what your business model is, and number two, give you some ideas about how to adjust or change or challenge that. Now, I mentioned that wireless connectivity is the driver for most of these changes that we're seeing, we're going to experience. But the primary driver, which is internet connectivity, is also going to end up being the primary limitation of all of these innovations. And so this chart I really like right here. It shows you the percentage of people in each of these areas. It's a nice map where the countries have been adjusted in terms of how many people are online, have online capabilities. And what you'll notice is that here in the United States and in Western Europe and in parts of Asia, there's lots of connectivity. But if your partners, if people along your supply chain are in some of these areas where it's not as tightly connected, you may have to think about that. You may have to consider that. You may have to consider that element as you're considering these new business models or elements of business models. So just something to keep in mind that, you know, even though internet connectivity and wireless connectivity in plants and between suppliers is something that is driving innovation right now, it's not, you know, you can't make the assumption that you always have that connectivity all the time. And this map highlights that point. So we've talked about production systems. We've talked about what a business model is and how you innovate on a business model, and the presence of ubiquitous connectivity that's enabling these new business models that we will have to ensure quality with respect to. So what does this mean for quality management? Like I mentioned earlier, we're going to see a shift towards humans and machines working alongside one another to humans and machines performing in a much more integrated way in a hybrid environment. Not only is that synthesis going to be part of our workforce, but we're also finding ourselves embedded in a different kind of innovation ecosystem. And I'm going to show you in a few minutes a map from the Institute for the Future that you can use to characterize your local innovation ecosystem, because you know, the things that you used to only be able to do by investing in really expensive assets that you would then have to, you know, house in a warehouse, and that you would have to manage, you know, transportation between suppliers. All of those things that used to be very expensive and very overwhelming in a lot of cases, especially if you were only producing a small product. You know, if you weren't scaling up, that now there's far more opportunity to achieve those sorts of things without making those big investments in fixed assets. So ASQ Future of Quality Report had a lot to say about this, and they basically outlined 10 different areas from which I extracted several drivers. So some of the things that are going to be driving business model innovation are things like this. You know, we've been focused for decades on efficiency. You know, efficiency has been and productivity. These have been the core elements of quality management. But now adaptability is becoming more important. We have different elements of that innovation ecosystem. We have lots of changes going on at many, many different scales. So adaptability is going to become a core competency. Another thing that's significant is that we're going to see a shift from shorter to longer term planning horizons according to the Future of Quality Report. In fact, they suggest that we may want to look to planning horizons that are up to 100 years long. This is kind of interesting to me because last month I met a guy who is the futurist. This is, I think, its job title for Autodesk. And he's been tasked with envisioning where Autodesk technologies might help manufacturing 100 years from now. so that's his job, to think about these very long planning horizons. And it's through those long planning horizons that sustainability and attention to renewable energy sources really makes a big difference. Another thing I wanted to touch on is that smart manufacturing, which I'll have a slide on in just a minute here, is a way to redefine seams and transitions. I thought this was really an interesting concept from the Future of Quality report, because seams are the boundaries between what we consider our organization and other organizations, or possibly even boundaries within our organization across which information has to flow for us to get jobs done. And transitions are the flow of energy across those seams. One of the interesting things that I thought from this definition is that just having manufacturing systems that are highly automated, where the pieces and the parts are moving through these assembly lines by themselves, and with RFID chips on them or other things that allow them to intelligently flow through that system and that allow for the system to reconfigure itself. This is going to redefine how we see our organization. We've been fighting silos for a long time, but this increased connectivity means that we can take a different look at what we think are boundaries, not just within our organizations, but also between organizations. And it goes on even further. We can reconsider what we thought was a boundary between our organization and our customers. That boundary too, that seam, and the information transfer across that seam is changing. I mentioned supply chain omniscience. There's, with the ability of things through the Internet of Things to talk to one another and to share information, we're working towards a state where the supply chain should have very, very good real-time information about itself. And it will be able to adjust and reconfigure just based on how its parts communicate with its other parts. And that's kind of exciting, but also kind of frightening from the perspective of data generation. Energy markets were another trend that were highlighted. So instead of just receiving energy from an energy plant, from an energy source, there will probably be opportunities for production systems to contribute energy back into the environment. So for example, you could imagine having solar panels on the roof of your warehouse, and not only could you be generating power for yourself, but if you have excess power, you can put those back into energy markets. And so it won't just be a cost center, but could also potentially be a value center for particularly larger organizations. Boundaryless customer experience. So this is kind of interesting, because when you're designing for customer experience, one of the things that we're not accustomed to thinking about right now is that as the objects that we produce gain the ability to communicate with other objects in their surroundings, they also gain the ability to communicate with you, the producer. So you can imagine that you buy 5 different kinds of clothes, and somehow those clothes are all talking to one another, and there's companies that are then upselling you on the computer because they know how frequently you wear the clothing, because the fabrics, the smart fabrics, can tell when you have a clothing item that's maybe wearing out and you need to get another one. So that really redefines our ability to think of customer experience, because not only can the customer's things talk to their other things and gain information about the customer and the environment, but this goes through the entire life cycle until the very end of the product's life cycle. And we're not used to thinking about customer experience all the way through the end of the life cycle. So with all of these different entities floating around in this very much larger ecosystem that consists of our things and the processes through which our things flow throughout their entire life cycle, it also becomes more important to honor individual variability. So there's natural variability in people, there's going to be natural variability in products, and you have a scenario where there are people and products are moving through their life cycles, learning about their environments, learning about each other, and what this ends up with is a combined production system where self-awareness becomes a huge, you can imagine someone working in a particular job position, but instead of monitoring their performance, that you basically, self-awareness is a skill, and their performance is measured by how self-aware they become about their participation as an information producer and exchanger within their community of people and machines. So these changes are all slow, but they're all happening at the same time, and pretty much all of them are rooted in the hyperconnectivity that is becoming something that we can work with. So these are all business model drivers that you can pull out of the cases from the Future of Quality report. I mentioned that smart manufacturing and cognitive production systems would become more significant as we're redefining those themes within our organization and between our organizations and our suppliers or our customers, as well as the information boundaries between them, those transitions. And one of the things that's good is we're already accustomed to a lot of these elements. So that's a relief. Some of these pieces of production systems that are going to be new to other industries, that they're really not as new to people who have experience in industrial control systems. The only difference is that this connectivity is there. The second difference is that there's more intelligence embedded in agents throughout these production systems. So the loops, the knowledge and information loops are going to tighten. So we have humans in the loop, but with the pieces of these production systems being information producers and information consumers, it's gonna tighten the time frame. The lag between producing information and getting it is going to shrink and shrink and shrink, and this is going to provide us with lots of opportunities for creating improvements that right now may seem out of reach. So smart manufacturing are all those pieces brought together. I have a video that I'm going to show you, a 4-minute video that I'm going to show you in just a second. So for those of you who haven't seen what a futuristic plant that uses smart manufacturing and augmented reality looks like, you can see that in just a second here. So I just mentioned augmented reality. If you haven't seen an augmented reality app yet, these are pretty interesting, and this is going to provide us a way to redefine our whole concept of visual factory. So if any of you have kids who play Pokemon Go, or maybe you play it, augmented reality apps are, you use your phone, you put your phone in front of a real system, and there's information that is superimposed on the real world behind you. So in this picture right here, you can see someone is using their phone to take a look at a part, and the phone captures the image of that part and provides you with additional information about what it is, or perhaps there's links to the 3D solid models, or maybe there's links where you can check into your supplier's inventory. Maybe you need a replacement part. Augmented reality is a series of a collection of interfaces that provide you with information that you might get through visual factory type approaches, but kind of in situ. So moving around your operations and being able to see that information in real time. Augmented reality is related to virtual reality. The difference here is the level of immersiveness. Virtual reality has become more prevalent over the past couple of years, mainly because the cost margins have really gone down. Virtual reality systems have been in use for simulation, particularly for the military and for pilots for up to 20 years now. But these technologies are becoming more accessible to all of us. We have a headset downstairs, an Oculus Rift, that I think costs about $600. You can see the guy in the top right corner of the screen. He's put this virtual reality headset on, and it allows you to jump into a 3D immersive world. You can look up and see what's on the sky. You can look down and see what's on your virtual floor. You can look behind you. So for example, for virtual reality films, which there are some available now, one of the interesting things is that you can often, you're watching a film in front of you, but you can turn your body around and you can see the whole film crew behind you. So VR is, some of you may have these in your operations right now, but research has shown that the VR systems are really effective in improving training, helping your operators gain situational awareness, and also, and this is the one that I thought that was the most cool, evaluating operating procedures. So if your simulation systems have predicted that a certain operating procedure is one that would improve one of the quality attributes that you're going for, you can have your operators immerse themselves in these virtual environments and step through the design procedure and save lots of money by having them embed themselves in the procedure and can identify issues before you implement them, and then they've spent a lot of time and effort and money. So the combination of augmented reality and virtual reality, there's some companies, Schneider Electric, which also is the vendor that now has Wonderware. They have something called immersive virtual reality plant. So definitely not mainstreamed yet, but worth a look if you haven't seen it yet. So both augmented reality and virtual reality apps are related to this concept called ambient intelligence. This is a concept that's been relegated to research for the past 20 years. Basically, the idea is that, imagine if you're in an environment where every entity in that environment produces information, consumes information, and can act as an intelligent agent, taking actions towards goals that are appropriate to your business. What you end up with in a system like that, where you have a collection of agents and some are humans and some are machines, is that instead of taking the approach that is usually taken now in business intelligence, where you identify what your analytics are, you use leading indicators and lagging indicators to try and to generate these metrics that tell you how your operations are going and how you're performing towards your operational and strategic goals. Instead, you have a situation where all of these entities are moving around, and just like people moving through the world, they have some information attached to them, but they also know what information they're looking for. And as they come into proximity with other entities that can provide some of that information, you may be able to ask for analytics or to have those entities learn about possible pieces of information that they could then use to get analytics. So and there was an article written by Jim Evans that I think was published about a year ago, emphasizing that in quality we really need to focus more on the value and the role of analytics. And I think this is one of those reasons, because over these next 2 decades, as we move into this human-machine hybrid environment, we're not going to be able to predefine which analytics we want to look at. We're going to have to define what kinds of information do we want to watch out for, and then imagine that all of the components in our production systems are out there observing their worlds with these ideas that they have stored in them, and they're out there watching for these opportunities on our behalf. So it's a science fiction-like future potential state, but the research has been going on this for the past couple of decades, so definitely not out of reach. So here's the 4-minute video that I want to show you. This is for anyone who hasn't seen a smart manufacturing system that is really advanced. If you want to look for examples, or if you want to do benchmarking, a great place to look is in the plants that are in Germany and in Belgium. That's where a lot of these systems are found. I think the one that I'm going to show you is in Germany. So this is about 4 minutes long, and hopefully this will be okay for your screens too. So here we go, 4 minutes.
People are at the center of what we do. Things will not be any different in the future. But what will customers want in the future? They will demand a wider range of variants, as well as more personalized products. It must also be possible for production to adapt quickly to changed market requirements. Adjusting to this new situation is a formidable challenge. Industry 4.0 is the response to this challenge. But what does Industry 4.0 actually mean? It means that the Internet of Things is finding its way into manufacture. In the factory, production will be connected. People are in control of this fourth industrial revolution. One of its features is the global connectivity of value chains across companies. For example, the configuration and personalization of cars will take on a new dimension in the future. It will be possible to freely select the size and shape of the car's information display. No two cars will ever be alike again. They will be individually tailored to customers' needs. The automaker generates design data from the 3D model and sends the data to various suppliers. There, the data undergoes a final virtual design and testing process. This is how the personalized information display we saw earlier will be created. Planners then determine which process modules are required for manufacturing. There will hardly be any more need for special machinery. Planning and modification cycles will be significantly shorter. The in-plant flows of supplier parts and finished parts will also be optimized. The production process starts from virtual representations. The Internet-based system then puts together the ideal manufacturing line on the factory floor. An associate puts the individual modules in the correct position, or they take up their position in the line automatically. Autonomous rollers ensure efficient plant logistics. At the Competence Center at a completely different site, experts are already beginning to train identical process modules for their tasks and make the manufacturing parameters available. The modules are ready for manufacturing immediately and produce 0 errors right from the very first part. Rejects are a thing of the past. The display knows which process modules it needs and maneuvers automatically to them, depending on availability and requirements. A wide variety of products now pass along a single line. The finished product is packaged and sent to the automaker. Sensors on the packaging detect the condition and position of products and transmit this information to the Bosch IoT cloud. This makes it possible to continuously monitor product quality along the supply chain in real time. Manufacturing will offer us far more than we ever thought possible. More versatility, optimum resource efficiency, and products that are more personalized than ever before. As designers, users, and decision makers, it is people who will assume the most important role in manufacturing. Industry 4.0 will drive the creation of solutions that make work a lot easier and satisfy customers' demands for tailor-made products.
Okay, so we saw a great example of supply chain omniscience in that video. The enterprise is completely connected, and you can track each of the components at any stage of its production, and you can not only can you track it through the production, but you can also track it as it goes on that truck, connecting different organizations together. What could possibly go wrong? And we're going to get to that in just a couple slides here. So, of course, what can go wrong is that, when everything is so connected and so reliant upon the network for information transfer, then if the network is not there, or if the network is somehow threatened, then unfortunately your supply chain is going to be disrupted. But before we get to that, I mentioned that the maker culture is an extremely important part of the innovation ecosystem now. And this map right here is available from the Institute for the Future, iftf.org. And although all of their initial work was done in San Francisco, which has a really rich and vital maker community and integrated arts and makerspace community, it kind of shows you how different cities could become rich, vibrant innovation ecosystems. So this Institute for the Future map, there's basically just four ideas, four things that you need to do if you're trying to figure out what kind of local innovation ecosystem are you situated within. And so you start with the pink block right here. Choose your open city strategies. Basically, this involves trying to figure out what free equipment is available to you, particularly if you're a small business and you can't afford those ultra-connected enterprises like we just watched. See what resources are available in your local community. This is one of the things that we're doing right here at our university right now. There's several departments have pieces of equipment. We have a CNC machine and a lathe. There's another department that has several 3D printers. And we've realized that we need to help our students understand what equipment, what sorts of capabilities, not just equipment, but what sorts of people with skill sets are available to them, if they have this fantastic idea for a product that they want to prototype and then eventually scale that up possibly. So step number one, figure out what is available to you locally. The second one is the blue box right here, technology catalysts. This involves finding out who is in your local community. Things like social events between people who are technologists in your community. Those can be very helpful in opening up your idea of what resources in terms of people and equipment are available. The third box right here, creating and combining maker platforms. Not only do you need to understand what sorts of equipment for design and prototyping is available in your area, but this even extends to things like art. What does the art community look like? What sorts of what instrumentation is available to the artists? Are there artists who work with steel who would be interested in working with small business? A lot of times that you'll find artists are very willing to work with small businesses in particular because they enjoy sharing their skills, sharing their equipment, and being part of innovation. Another part of this green section right here is the role of surveillance and participatory governance, which our view of these things is rapidly changing. There's lots of very current research that relates the surveillance status of our cities and our industries and participatory governance, and all of these ideas are very in flux right now. So the fourth stage right here where it says immerse yourself in future visions, that purple part, that basically is intended to show you that there are other cities around the world who have made it one of their civic goals to demonstrate what a really healthy innovation ecosystem looks like. And so you can use these cities as design patterns. If you go to instituteforthefuture.org, they provide lots of information about what makes each of these 8 cities so unique as innovation ecosystems. And if you're coming at it particularly from the perspective of a new product developer or a small business, this could provide you with some ideas about local efforts that you might want to participate in to increase the strength of your local innovation ecosystem. So what's changing? There's basically 3 things overall that are changing, and this influences the direction that we need to think as we're trying to figure out how quality management is adapting. Organizations are changing, customers are changing, and the power of information is increasing. As far as organizations go, we're seeing more automated systems that are connected to the internet. We're also seeing more of these maker cities, whereas it used to be just places like San Francisco years ago. Now there's maker cities all across the United States, and even places in other countries are dedicating themselves to cultivating these open innovation ecosystems. Another thing that I like to tell my students is that, if they have a great idea and they can use local instrumentation, local makerspace technologies to prototype their ideas, it's a lot easier now than it used to be to find suppliers and to find manufacturers of components to scale up your operation. In fact, we have one friend who's a serial entrepreneur, and he lives in San Francisco. And one of his most recent companies that he sold was basically the recipe for a dietary supplement. And so he created the recipe. He found the locally sourced ingredients that he wanted to put in there, and he never touched one part of the supply chain. He was just the broker that connected all the people and got those products made and out to his customers. And once he linked together all those pieces of the supply chain, he was able to sell the company and just did it from being the broker of information. So he's a great example of how organizations are changing. Customers are also changing. I think one of the biggest ways that it's evident customers are changing is that there's a lot of new business models that don't rely on ownership or consumption. And anything that's related to the sharing economy falls into that category. Power of information is also getting more powerful. I've talked quite a bit about how the landscape of the organization is going to change when all of the things around you, when all of the entities can exchange information with each other, when they can make decisions without a human in the loop, which is pretty much the norm now. Technologies like virtual reality and augmented reality, and the fact that you can walk into these virtual environments and analytics can learn about their need to provide you with information by your presence in these environments. This means that there are more types of information that it will be possible to communicate. And the one that I want to emphasize is that recent research has shown that in the virtual reality environment, it's very, very easy to cultivate feelings of empathy. So imagine, if you had a technology that you could use to connect with your customer, imagine if empathy was one of the forms of information that you were thinking about in terms of designing your customer experience. VR technologies are making that possible right now. And then finally, in terms of power of information, in the very, very beginning, Jose mentioned that cybersecurity is an essential component of quality now. And the reason why is that, and this is just something that's changed over the past few years, but information now, it's not just stealing information and stealing identities, but information now has the power to damage or destroy physical assets. You can use information to change the way in which your PLCs do their job in your manufacturing system, and you can, in the case of in 2010, 30,000 centrifuges in Iran were rendered useless in their nuclear program because of a virus that got in and infected the PLCs in their plant that had the centrifuges for creating nuclear material. So information now has the power to damage or destroy physical assets. That's why cybersecurity is so important, not so much that you can have your identity stolen or your personal information stolen, although that is really important too. So this, I just wanted to make sure that you had these resources with you and know that they exist. Getting into cybersecurity is a huge endeavor, and I don't intend to get into it at all here except to raise your awareness of the fact that it is an issue of risk management to your physical assets now. NIST has come up with their framework for improving critical infrastructure cybersecurity. It consists of a document plus a spreadsheet plus pointers to lots of standards that you can use. It's very long and it's very in-depth. What the Baldrige program has done is it's taken their Baldrige-Burger concept, the 7 facets of looking at an organization, and they've interpreted the NIST framework to provide organizations with a question and answer book that reads very much like the Baldrige criteria do. So if you have experience using the Baldrige criteria, using this should be at least a straightforward process that can help you get into understanding, how can I address cybersecurity in my company, whether it's a small business or a large business, doesn't matter. The Baldrige program did a great job at ensuring that this new tool, which just came out in September, can be applied to organizations at all scales and at all levels of maturity in cybersecurity. So I just wanted to leave you with these resources. And like I said in the beginning of the presentation, I will be posting these slides to my blog at qualityandinnovation.com. So that's where you can get all these links. You don't have to be writing them down here. So this leads me to my final point, and that is, this thing I call industrial neurodiversity. What is it? And basically, it's an idea that I want to start spreading among all of us in the quality community, that we are on the verge of this collection of humans and intelligent agents working together. And when we look at, if we have an intelligent agent in our life and its job is to be a spam filter on our email and to tell us whether a particular piece of email coming in is spam or not spam, we don't judge that intelligent agent on the fact that that's the only thing it can do. We don't say, well, yeah, it's intelligent, but it only does one thing. We accept that all of these different individual pieces have a specific role and specific capabilities and specific things they do really well and specific things they don't do well at all. And I think that's the way that we should start shifting our attention of humans in the environment too. Deming was never a big fan of performance evaluations, and I think his philosophical reasoning for that is going to become more and more pronounced as we move towards this environment of human-machine hybrid performance. So I wanted to show you I just have a couple of slides defining what I think this concept, this discipline of industrial neurodiversity will be in, that we find ourselves in, and it's rooted in the neurodiversity movement. So the neurodiversity movement it takes a look at cognitive developmental disorders, things like autism and ADHD and dyslexia and dyspraxia. And the neurodiversity movement says, let's not look at these things as disorders, but let's look at these as natural variations on human cognitive performance. So, instead of putting people in a bucket and saying they're disabled, let's accept that perhaps the way their neurology works, even though it's different than us, perhaps it can teach us something about how we think and about how we relate to one another. So the entire neurodiversity movement, it's very much related to accommodating what now are called disabilities, but neurodiversity movement says, let's take a look at this from the perspective of where are the good things here? Where are the things that we should accentuate and really value? And it's a different way of looking at things that you would previously perceive as liabilities. So if we want to take a look at how these cognitive and sensory developmental disorders relate to the workplace of the future, which I think will be fantastic, the two things are brought together. One is the level of logical intelligence that you might introduce into your systems through things like machine learning and applied artificial intelligence when you have this workforce of intelligent agents. And just in case you don't have a backdrop or some sort of a framework for understanding what machine learning algorithms do. I just wanted to put this slide up there to give you some examples of things, different tasks that machine learning algorithms can accomplish on your behalf. But the reason why this is significant is that machine learning algorithms are embedded in intelligent agents. Intelligent agents have percepts. This is that PAGE acronym on the left-hand side. They have percepts, which means they sense different things. They use those things that they sense to take elemental actions. That's the A. Those actions together allow these intelligent agents to achieve goals. That's the G. And all of these percepts and actions and goals are embedded in an environment, whatever environment it is you're deployed in that you have to operate in. So PAGE is an acronym that relates sensory intelligence, so the things that you can sense in your environment, to the actions that you have to take and to the goals that you need to make sure those actions are directed towards. So the key here is the sensory intelligence. You take information in through your senses or through your percepts, and they can be physical senses or they can be machine senses, things that you sense from machine sensors. And if you put those kinds of senses together, so that the senses that a machine can have and then the senses that your human body has, those senses extend from just having information available to you, which is the upper left-hand corner of this slide, all the way through, putting those physical senses together into your sense of self. Once you have a sense of self and body and you've oriented your body in space, then you have a sense of what your emotions are and what your feelings are. Once you have a sense of your own feelings, you can gain a sense for other people's feelings, and this is halfway down on the left-hand side here. Once you are able to understand that others have emotions, you gain a social sense. You can interact with them. You can relate to them. And then when you go deeper, eventually you get to the empathetic connection that is a driver of designing for your customer experience. So if you take this scale on the left-hand side, from the top left down to the bottom left, if you think about sensory intelligence all the way from the physical things that a machine can sense, all the way down through the ultimate goal, which is complete and utter empathy, or transcending boundaries between people, that's a scale of sensory intelligence. If you take a look at that horizontal axis, when you look at all of the virtual and augmented reality technologies, they're just part of a bigger reality continuum. So on the left-hand side there, you'll see diminished reality. Basically, you can put those virtual reality headsets on and have them blank out a lot of the sensory experience around you. And this can be really useful for helping you or your employees focus, for helping them, achieve the levels of attention that you might need them to do, particularly, if you're in operations that require lots of intense focus. So you can take a look at this virtuality continuum as there are different environments that are going to be available to us in our workplaces over the next 10 to 20 years. And we can drown out a lot of the sensory stimuli through diminished reality applications, or the Earth is in the middle because this is the reality that we perceive around us, or we can augment what's around us with additional information that we maybe see through our phone, looking at the environment around us. And then as you move to the right, you can get virtual environments that are more and more rich and immersive that you can then operate in. There are lots of disciplines emerging around different combinations of sensory intelligence and virtuality of your technologies. So this map right here, this is my map of industrial neurodiversity, because I believe that 20 years from now, that people and machines are going to be not just working together in a hybrid environment where performance is measured as a result of that hybridization, but we might also have hybrid bodies. Our bodies may be augmented with technology. so that the boundary between us and the intelligent agents in our environment even extends to the seams and transitions becoming indistinct within our own bodies. So there's your bit of science fiction. This is bringing in lots of information from lots of different fields to create basically a futuristic view of what might be in store for us. But just like science fiction writers of the past had to look at things that were not possible or things that were only slightly within reach in order to generate the extreme value that we've seen from technological innovations and process innovations. We're kind of in the same position now. So let me be the science fiction writer of the quality profession right now, just to help you open to the possibilities that may be on the table. If you're not quite ready to go that far, let me leave you with this. How can we adapt right now? And if I had to boil everything that I've said in the past hour down to just a few points, these are the few points that I would like you to hold from this point forward. First of all, quality will not be limited to the point of production. Intelligent agents, not only do they have sensory intelligence, but they learn. Intelligent agents learn. You may need to consider that quality assurance does not stop at the point that your product is available to your customer. Perhaps in your product innovation, perhaps your product will continue to learn about your customer and continue to learn about the environment in which your product finds itself with your customer, and perhaps your product will continue to communicate with you all the way until the product ceases to be able to perform its function due to physical limitations. So quality assurance is possibly going to extend all the way to end of life of a product. Second thing, in this future and in the very near future, analytics will be available everywhere and by request. And the mental model that you can use to think about analytics is the same way you think about all the people in your organization. All the people have certain skills, they have certain talents, they have certain things that are already in their heads, and they have ways of getting information. And we tend to do really well at understanding, oh, well, this person is very good at this particular thing, or this person knows a lot about Six Sigma, or I'm just trying to think of some kind of topic that someone might know a lot about. And we know who to go to find these things. So I think it's just going to be an extremification and much more of that, but where we know that a particular machine is good at something, or a particular machine can find us this information. So there'll be a combination of the humans and the machines being able to do that. Voice of the customer, we think about asking people right now, but we're going to be able to get voice of the customer information from objects, and that is a very, very near future type thing. So, when you're trying to go out and figure out what your customer requirements are, think about if you can plant sensors. Of course, you're going to have to tell people what those sensors are, and what kind of information they're collecting. But can you collect information about your customer requirements more autonomously? So voice of the customer doesn't necessarily have to come from the customer. It can come from their stuff or their environment. And what this also implies is that continuous learning is not just going to be something we do for competitive advantage. All of these entities are going to be continuously learning about you and about each other, and things are going to be learning about each other throughout their physical lifetimes. And bottom line, again, because information now has the capability to damage or destroy physical assets, sometimes very expensive assets, to make physical changes to systems. Please start integrating, if you haven't done this already, start integrating cybersecurity considerations, possibly through the Baldrige tool, into your quality systems, because it's going to be compulsory in not too long from now. So that's all I have. hope you found at least one nugget that's enjoyable about this. And like I said, I'll post the slides at qualityandinnovation.com, and feel free to email me or tweet me if you have any other questions. But I hope you've enjoyed this science fiction foray into the quality future. Thanks.
Thank you very much, Nicole. I'm pretty sure all the participants have enjoyed the presentation. I know that we are over the hour, but we have one question for one participant, if you would be able to answer.
If I can.
Yeah, so the question is, how do you think this will impact the nature of market transactions, product ownership, and billing and payments? Obviously, this is more on the servicing side. What is your vision on how quality management is going to affect that type of industry?
I don't know yet. What I do know is that different forms of currency are being explored. I'm sure everybody has at least heard of Bitcoin and cryptocurrency. I'm pretty sure that the cryptocurrency in its current state is not going to be what everyone ends up using, but it is leading to some really interesting philosophical discussions about how we demonstrate value. And so I think that for us, how we demonstrate value and you know how our customer recognizes us for delivering that value to them, that transaction may very well change before we move to different currencies. So yeah, I'm still trying to figure that out right now. I'm trying to figure out, you know, very simple things like how can I develop an exercise for my class where the students can understand what proof of value means. And so I'm in the process of doing that. I'm going to try and get that by sometime at the end of the spring, and maybe that'll shed some light into this question. But I think we're still at least 5 years out from knowing the answer to that.
That's great. That's great. Well, I think thank you very much, Nicole. It was a really impressive presentation. As you said, I'm pretty sure participants now have some idea of what industry is going to look like on the next 10 to 20 years. So very impressive. So just to all the participants on this webinar, as Nicole mentioned, she's going to post the presentation at her website, qualityandinnovation.com. And this recording is going to be available also at the ASQ Innovation YouTube page. So when you're on YouTube, just type ASQ Innovation, and you're going to see our channel there. So it's going to be uploaded there as well. And our next webinar is going to be on December the 12th, a Monday as well, and the title is going to be Innovation 2.0. So hopefully you also can join us in that webinar. All right, so again, thank you very much, Nicole, and now I'm going to stop the recording. Thank you, everybody.